In this video we're going to look at straight lines and how to determine whether they are parallel to each other or perpendicular. So if we have two lines, line L1 defined as y is equal to x plus c1, where m1 is the gradient and c1 is the y-intercept, and then L2 is defined as y is equal to m2 x2 plus c2. We want to know what conditions of m and c lead to the lines being parallel to each other. Turns out c is irrelevant in determining this, and this makes sense because c is just the y-intercept, so all c does is either move the line up or down, but that doesn't change what we consider like the angle of the line, the gradient. So it doesn't affect whether we're parallel or perpendicular. So m1 equals m2 implies, and this is also a reverse implication, implies L1 and L2 parallel. So yeah, if L1 and L2 are parallel, this implies M1 equals M2, and if M1 equals M2, that implies L1 and L2 are parallel. And then also, if M1 multiplied by M2 is equal to negative 1, L1 and L2 are perpendicular. Parallel, by the way, just means that the lines either never meet or they meet at every single point. If a line with itself is parallel with itself, but the point is they never get any closer to each other or further apart. They always stay the same distance from each other, and that now makes sense why the gradient has to be equal. If one gradient was larger than the other, then it would the distance between the two lines would be changing at every point. Perpendicular means the two lines meet at a right angle. Okay, well, all these sides would be right angles, but yeah. So this also makes sense now, because if you look, m1 would have to be equal to minus 1 over m2, which means one of the gradients is 1 over the other one and in the opposite direction, which does make sense. So now we're going to define a line y is equal to 3x plus 5, and I want to find the set of all lines which are perpendicular to this line. So we're going to call the new gradient, we're going to define that as m, and we know from this formula here that 3, which is rm1, m's rm2, so 3m is equal to minus 1. This implies m is equal to minus 1/3. So our new line takes the form y is equal to minus 1/3 x plus c, and c is just some real number. And here we go, that's our set of lines which are perpendicular to this point, this line here. A question might ask you to find a line that's perpendicular to another line and also passes through another point, and in that case you'd substitute that point in as y and x to find your c, and then once you found c, you'd write in the form y is equal to minus 1/3, minus 1/3 in this case, but it obviously won't always be that, and then plus this particular value of c that you found. Okay, so if we're just looking for a set of lines which are parallel or perpendicular to another line, we're just going to have a general c coordinate, but if you're given a coordinate, then you can find your a particular value of c. Okay, that's all we're going to look at in this video. If you do have any questions, then please just let me know in the comments. If for some reason you're not familiar with this y equals mx plus c, check out the last video on the equations of the line. Yeah, that's it. Please like and subscribe, and I hope to see you in the next one.